Second one we're going to deal with is introducing, Jacob, did you do variance, standard deviation, or correlation earlier?
We just saw the result, like standard deviation as a result of describe, but we didn't see the actual dot. What is it?
Yeah, that. Okay, so I'll just briefly introduce those, so some more stats functions. We can just use the same data set for this to make it easy. Okay, so we like temperature, so you could do print data.temp.var. That gives you the variance. Print data.temp.std, standard deviation, which is the square root of the variance for those who've taken stats. Standard deviation, square root of variance. We could do print data.corr. Okay. So if we have many variables, which we do in this data frame, so let me just show you, scroll back up. So this is our data frame. Here's all the data. Nope, that's the wrong data frame. Right, we have these 6 different variables. And you might be curious, how do they interact or relate to each other? Those in stats software, you've done correlation matrices. In Python, it's just .corr. So this is a correlation matrix in all 6 of them. 1 means they're completely correlated, so that's pretty useless. Everything above and below is equal. It's a triangle, so you could get rid of all that and really just look at these lower values. And then, based on your stats knowledge, you can interpret them and so forth. Correlation is R squared for those who've taken stats. So it's how strong it is. We can look here and see that most of them are pretty terrible, but the best one's actually this, ozone and temperature, which we kind of think based on what we know, maybe know about science, that ozone and temperature have a somewhat strong relationship. And that wind and ozone apparently have a relationship based on this data set. So this doesn't mean this is true or false. But this is great. This is very common in stats to know correlation. And it was super quick. Right?
For sure.
And it actually might take like 5 or 6 clicks in SPSS and really quick to type in Python. So you're going to start to see that you can run stats very, very fast. All right, so that was the second of 8 lessons. Ooh.
That one went really fast.
Well, because the rest of it was like things that Jacob taught earlier. So Jacob did half my job for me. So good. All right. What next? Oh, this is interesting. I'm trying to make sure I teach what you guys want, because I have stuff on central limit theorem, but that can get very theoretical. So I don't think that's what you guys want. Things on normality with densities and figures, that can get very complicated. Skew, kurtosis, all these great things. They're actually really great, but okay, so I'm going to skip those. So we just finished lesson 3 and 4. You guys are on a roll. There's actually 5, 6, 7. There's 9 of them, so we're 44% through. Let me see.
These are all continuous variables in the data set.
Yeah, oh, this is great. So we haven't even talked about it yet. What's the difference between discrete and continuous variables? So who knows the difference? What is a discrete variable?
Discrete is a yes or no?
Yes or no, it's specific. I'm only drinking 1 cup, 2 cup, 3 cup, 4 cups of coffee a day. Continuous would be like, what is my weight, right? And it's always fluctuating. Every second I'm perspiring water, so I'm just like dying, right? Until I drink more water. Okay, so continuous means all values exist. It's like integration calculus, discrete specific values, like algebra 2. No, I don't want to do this. Ooh, I do want to do this because this brings us up to what Jacob was pressuring me to get to, which is stats models.
T-tests and stuff?
Yeah, so stats models gets into hypothesis testing. So show of hands, who's learned or knows hypothesis testing, t-test, f-test, z-test, p-value, confidence interval, or some aspect of that. We're going to introduce stats models, which is a package that can print that all out really quick, which is what you would do in SPSS also. It's not the best package. Scikit-learn is way, way better.
What's better?
Okay, so sklearn is really, really great because it's like a machine learning package, but the ramp up to learn it takes longer. So we're going to start with stats models. As you can imagine, stats models, is it stats models or stat model? Let me make sure Stats models. Yeah, so it's just a quick way to get that. So let's see what this looks like. Some more advanced stats. And we'll probably do stats for another 15, 20 minutes and then switch to SQL. But I'm just, giving you like a taste of seeing how you can do some really cool things with very, very small amounts of code. Okay, we're going to use a new data set now. Actually, do we need to? We can use our current data set just for purposes of time. Ooh, no, I really, really like this data set. Okay, let me open up the link. I'm going to teach you guys something new. I keep saying that just for fun.
It's like the purpose of this entire
Right? Hopefully. So if this URL works. Okay, this is a free, really cool stats book, which teaches you actually stats with R. But we're going to use their data set to do Python. So I'm going to put this link for you also in Etherpad, so never fear. Stats book for R, but Python data set. Okay, so that's going here. You don't have to click that, that's just for your reference. But on here, there's a data set I want us to use under data sets. And it's this one. Okay, so let me copy the link. Great. So I'm going to put the link here underneath the book. There's this link. Stars are going above it, stars are going below it. So click that link and please download the CSV. We're going to, actually just kidding, don't download it. Why should we download it? You know what's great about data? You don't have to download it. You can use it from the web. You can actually connect to data sets from the web.
So the web is its own directory?
To the web, to the interwebs, that's right. So that's what we're going to do now. So let me show you how to do that. But just for your reference, like this is the link because it is. That's not the link, that's stars. Right, so that's our link. But let me show you what we're going to do. So we are just going to create a data set. So let's call it advertising. And it equals same pandas method, PD, not there, pd.read underscore CSV. But instead of going to a directory, you can go to a website. So we could actually, you guys will have to type it unfortunately, or you can copy from Etherpad. But you can just write the whole website where your data is. And then it pulls that. If it's public data, right? If it's not like requiring a username. If it requires a username password, there's ways to do that also. But right now, this is just a public data. So you can type that. Actually, yeah, that looks like it's spelled right. And if you don't want to have to spell it, it's here in the Etherpad with the stars. So you can just copy that link and then paste the link. And then I was mentioning earlier about this index call equals 0 thing. So let me show you what that does. So let's do it without that. So if I just shift enter and I'm going to print advertising, looks like this. And we have an annoying little issue that Python doesn't resolve by itself, that if whoever created the CSV created it badly, you have these extra rows that duplicate or repeat the key rows. So the simple solution to remove that is to set your index column to be 0. And by doing this, we just removed a column. And now we are having each row being the number it should be. We could technically say let index column be 1, and then we put the TV column first, right? So we could reorder columns. This is just weird at this point, right? Index column's 2, you know, well, maybe it's not working. Yeah, now radio and so forth. So generally we do 0. Like we're just removing that extra row. That's what we'll do most of the time in Python. So that's what index call is, to select what's the first one. Okay. And instead of just printing advertising, a better habit to get into, because this prints all of it. It's very nice though that usually they split it. So like they only print like the first 20 or 30, print the last 20 or 30, but that's still not effective. So it's just better to typically do like either print advertising.head or just advertising.head. Right? So because we don't need to see all of it and take up tons of space. We're killing trees on our screen after all. Okay, what's another one that's interesting? We can do advertising.shape. This shows you the shape of your data. How many rows by how many columns. And now I'm going to do some more scatter plots, because I love scatter plots. And so does Jacob. We're scatter plot maniacs.
Plot for life.
Yeah. So, so far we've learned like one at a time, but what if you want 3 scatter plots side by side by side? There's a way to do that. Do we have all our packages imported first off? We have pandas and matplotlib. I think we have them. Yeah, okay, they're all in. Great. So I'm going to say that let's choose figure and axes such that plot.subplots, so accessing matplotlib, I want to have one plot with 3 plots in it. And they're all going to share the y-axis, such that that's true. So I'm having a figure with 3 axes, all sharing the y-axis. And now I'm going to plot each scatter plot that I want. So I'm going to do data.plot, not data, advertising, right? That's the name of our data set. Advertising.plot, the kind is scatter. My x-axis could be TV. My y-axis could be sales, what I'm trying to compare against. And my axis is going to be the first one in the set of our axes. Our first position, which in Python, first position is 0. And then I can choose another dimension called figure size, how I want it to scale and look. So I'll just say I want it to be a 16 by 8 relation, like a 2 by 1 in essence. Okay, so let's see what this is. Hopefully it works. Ooh, lots of errors. Is the error because I don't have my other 2 graphs?
Sales isn't capitalized.
Amazing, look at that, guys. So Python is case sensitive. Sales isn't capitalized. That's why we have this issue. Initially, it will probably also look really weird because I don't have all 3 of them, or because I made them really big. So maybe I'll choose like 8 by 4, and now it's a little smaller. So maybe you guys could also switch yours to 8 by 4. And see, we've placed our first scatter plot. And if we want 3 scatter plots, we'll just repeat this and change our x. So maybe I want to compare to radio, and compare to newspaper. Notice neither are capitalized, so we better lowercase them. What did I do wrong here, guys? What is wrong with my code? Why did I suddenly get 3 data sets all in my first scatter plot? What do I need to change? Axis, right? Position 1, as in the second one, and position 2, as in the third one. And now we have 3 scatter plots side by side, doing some comparisons. 4 lines of code, it's a nice visualization. Green sticky if you're getting this up on your computer, red or pink sticky if this is not happening for you. If you're not getting it, one issue, check your parentheses. Second one, don't forget your apostrophes. Third one, check if things are capitalized or lowercase. Fourth one, brackets starting 0, 1, 2. Share Y should be lowercase, 1 and 3. So check a lot of your things. I promise that's probably the last visualization I'll do. Everything else is going to be more stats. But I just love scatter plots. Periods would represent the names of columns, or the periods would call on a method. But in this case, we're just indexing 0, 1, 2, so we can't do period 0. We can't do dot 0. That won't work. Was that what you were asking?
Yeah.
Okay.
Thank you.
Yeah. Okay, I think we're mostly there. Who needs some more time? Okay, no worries. Spend a minute. Just check the syntax. I guarantee if you... So we have to start doing linear regression, we can use one package called stats models. And we can import stats models .formula.api as SMF. That's the standard import for stats models. Okay, so import that. And now we're going to create our first linear model, linear regression. A couple people requested linear regression. So my linear model is the SMF package dot the ordinary least squares linear model such that the formula for the model as defined by myself, the data person, is representative of the sales column, which actually I think has a lowercase s. So make sure this is sensitive, right? Lowercase s. And then tilde is predicted by what variable? TV. Whereby, comma, the data is the name of the data set, oops, advertising. And we're going to fit that with the fit to the ordinary least square model. I know it's kind of low. I'm going to try to move it up. Okay, so this should hopefully work. Shift Enter. So now what we've done is we've stored the linear model, but we don't see anything. And the best way to see it is lm.summary. Let's see the summary of the model. And holy guacamole, we have ANOVA and p-value and confidence intervals and tons of yummy stuff. So first off, if you don't get this, red sticky, pink sticky, because we want to make sure you actually get it. And then I could spend a minute or two just talking about it. It's mostly stats concepts, so I'm not going to go in depth. But I just want you to be like, that's kind of cool that it shows up. So, yes?
Could you just read the equation again? Like, I know you said that it's like sales.
Yeah, so the linear model LM equals the SMF package dot the ordinary least square, because that's the method of just general linear model with residuals. Opening the parenthesis, such that this formula, it's always formula equals, and you can do it with one variable or multiple variables. So sales tilde, right? So the y is being predicted from x. The dependent is a result of the independent.
So it's y from x.
Yeah, or the predictor is the result of the attribute or the feature. I'm throwing all these words because that's like data science speak.
I just didn't want to get it the wrong way around.
Yeah, y is to x or x1 and x2 and so forth.
Okay.
And then your data set does it.
So if you wanted to do it for more than just those two, you would just add another tilde and add another variable?
No, you would actually create a list and you would put multiple ones with commas.
Got it. So
Yeah.
instead of hard brackets?
Mhm.
Do you mean, like, to do a regression with more than one variable, or to do other regressions?
Yeah, she means with more than one variable.
So it's plus, right?
Let's try it. Let's see what happens, guys.
This is supposed to, it's like.
Plus radio.
I think.
Like if it was on.
Yep, plus radio, so just plus.
Okay, so.
So we have plus radio, now we have another one. Plus newspaper. I don't use this package too often, I do more scikit-learn, but yeah, and then we have more variables. So that's cool, you could do plus, so now we're running multiple linear regression.
Right.
And that would take like many buttons in a software.
It even takes so long just for it to process.
Yeah, sometimes your computer takes a while to process, or if you're in a virtual machine or whatever, like this takes a split of a second. Let me explain the one that's just TV first, just to like high level explain you a little bit of the output. And I'll just explain with the multiple. And then we'll stop on stats, take a coffee body break, and switch to SQL. So first off, red, pink sticky if you're not getting output, green sticky if you are getting output. Okay, so everyone has gotten some sort of output. Cool. A couple students haven't. Okay. Let me just explain this to y'all. Most of this is pretty non-significant, but when you interpret this, just like SPSS, R square, very important, right? Typically, if this is 80% or higher, that's good. 60 to 80%, that's moderate. Less than 60%, your model is terrible, throw it away, try to adjust it. So that's super high level. P-value, prob of F statistic, that is your p-value. E means 10 to the, it's scientific notation. So 10 to the negative 42nd, that means you have 41 zeros and then a 1, it's almost 0. In general, p-value, we tested a 5% threshold for those who've done stats. So we're comparing to there.
Explain one more time, though. What is SMF?
Oh, that is the stat model formula, stats models.
Oh,
So
okay.
we brought it in through their API. We brought in their API to work with data, with their formula, which is this whole thing here, stats models. And we abbreviated it as SMF. Because otherwise, what you do if we don't abbreviate, we didn't really show this to you. I have to write every single time, stats models.formula.api. Like, let me run it like that. But it wouldn't work because I just have to do like that. And now it works. But I had to type this whole thing. Like, why would I ever want to type this many times? I could type the whole thing, but instead I'm just going to do as SMF because it's a shortcut. It just makes it look much nicer and easier to type. Does that make sense? Cool. All right, so we hit R square, prob of F statistic. What else is down here that's interesting? These are the coefficients when you create regression. This is your p-value for each variable. We don't care for intercept ever, but the variable is good. These are confidence intervals. We got other interesting stats things. And then we can, of course, add multiple variables. So let's do plus radio, plus newspaper. So you guys could do that as well. Do plus radio, plus newspaper. And what happens is your R squared changes. So actually in this data set, wow, adding multiple regression, way better predictor than just TV. And then down here, again, p-values, different confidence intervals, and we could interpret different things. But this isn't a stats class, so I'm going to limit how much I go too in depth on that. Show of hands, who finds this exercise helpful? This identifies the parameters for your linear model. Even though you can see them right here as coefficients, it just prints them out for you.
I'm just keeping you up to date.
And let me show you how we could do some prediction.
You can do multiple regression here.
This is multiple regression now. We just threw 3 variables here.
Oh.
Multiple linear regression. Yeah. So we can say I have a data point that's interesting. So I'm going to add a new data point. X underscore new is being added to the data frame, to the pandas data frame, pd.data frame. Or we're actually creating a data frame. So X new is a pandas data frame, such that we're inserting a dictionary that for TV, the value will be 50,000. Don't put a comma. Comma will break it. Numbers shouldn't have commas when you put them in. Because in Python, comma is treated as you're inserting something else, not actually like comma in a number. Okay, so we're typing, basically we're creating a pandas data frame, and in it we're putting a dictionary for the key TV. We get the value 50,000 as a one number list. And if we're interested to see what that looks like, we can print out the head. And we see that. It is literally a 1 by 1, like very small list. Okay. And if you want to predict this now, because I know in SPSS we do prediction, so how would we predict the model? Let's say linear model.predict. I'm going to predict the X new. So if I input 50,000 for TV, what will I output? Now before we do this will break because I haven't put anything for radio and newspaper. So let's go back up here and just make it up real quick. Comma, radio. Let's give radio something like, I don't know, 10,000. No comma. Thank you. And then let's do something like newspaper, and maybe give it like 5,000. And my syntax looks good. Let's reprint the head. Now we have very nice, structured all 3. And now if we do lm predict x new, you should spend, or your predicted advertising is $4,171 that you get back, if this was like an equation. So this just plugged in these 3 numbers for us into our multiple regression equation and told us the output, which you've probably done SPSS before. So also again, super quick. For those of you who've done multiple regression, this makes sense. For those of you who haven't, it may not make sense, but I kind of encourage you to learn it. One last interesting thing before we move on to SQL is you could do your linear model.p-values. And that prints out the p-value for every single one. Right, so that's often very important. Oh, another one. lm.conf_int prints out your confidence intervals for each one as well. So I'll be saving this file after and putting it for you guys on the Etherpad, because all this, I'm sure a lot of this is extremely helpful. All right, well, I only got through 6 of my 9 things and stats I wanted to cover. This was definitely outside the scope of the material today, so I apologize for some of you who this was maybe hard to follow along with, but I hope many of you found it helpful. Yeah?
Can you just let us know the topics that you are planning to cover in the other videos?
It's just other stats topics. Like I was going to teach normal distribution, central limit theorem, some other graphs. Like it's just standard stats things. It's just in Python, you'd have to learn how to do it. But
There are resources for us to look into that.
of course, yeah. I'm just teaching you like the nuts and bolts. Yeah, exactly. Cool. So let me save this right now and put this up on Etherpad for you right now, because we're about to move away from Jupyter.